This is section 6.3, Indirect Proof. All of the proofs we've done so far in this class are what are called direct proofs. We have a statement we want to prove, we start with the hypothesis, we end with the conclusion. An indirect proof is different. And so to see how it's different, I want you to think about this question. If I were to walk in from outside with a dry umbrella, and I show you that dry umbrella, then what can you conclude? What do you think? No? That's right. You can conclude that it must not be raining. It can't be raining. Because if it was raining, my umbrella would be wet. So that's kind of how an indirect proof works. What it does is assumes the opposite of what you want to prove, and then you find a problem, and you know your assumption had to have been wrong, which means that what you wanted to prove is true. So in an indirect proof, and you should write this down, you begin by assuming temporarily that the desired result is not true. Then you reason logically until you reach a contradiction of the hypothesis. Because there is a contradiction, the temporary assumption that you made is impossible, making the desired conclusion actually true. Now that probably makes no sense right now, so we're going to do two examples. You should write both of these down. First example. You're given that n is some integer and n squared is an even number. You want to prove that n also must be even. But here's how the proof would work if it's done in an indirect way. You assume the opposite of what you want to prove. If we want to prove that n is even, we are going to assume the opposite of that, which means we're going to assume that n is not even. What do we call a number that's not even? We call it odd. So if n is not even, then n is odd. So we've made our assumption. N is not even. What we're going to do is go through and take that statement and prove this using that statement, but we'll find a problem. We'll find a contradiction, which means our assumption can't be correct, which means n must actually be even, because it can't be not even. So here's how we get a contradiction. Since n is not even, we know n squared just means n times n. Then n is odd, so n times n becomes odd number times an odd number. But an odd number times an odd number, like 3 times 5 or 3 times 7, an odd number times an odd number is always an odd number. So that means that n squared is an odd number. But that's a contradiction with our assumption up here that n squared is even. So we have a contradiction. Since n squared can't be both odd and even. So it's kind of in your thought bubble. So in our proof we write contradiction. Thus our assumption must be wrong. So n must be even. Since we had assumed it was not even and found a problem with that scenario, then it must be that n is even, because that's the opposite of being not even. And that is what we wanted to prove, that n was even. So we got it in an indirect way by showing that it could not be odd. And if it's not odd, then it has to be even. So an indirect proof basically shows that the opposite can't be true. That the opposite of your conclusion can't be true. So your conclusion has to be true. Here's our second example. This will look more like a traditional proof. We have trapezoid PQRS, and the bases of the trapezoid are PQ and SR. We want to prove that PQ and SR, the two bases, are not equal. We know it's possible for the legs of the trapezoid to be equal, in which case it's an isosceles trapezoid, but we're going to show that it's impossible for the bases to be equal if it's going to be a trapezoid. So when we write the proof, we start with our given. We've got trapezoid PQRS with bases PQ and SR, and that's given. Our next statement is going to be the assumption we're going to make. So we're going to say assume. And we want to assume the opposite of what we want to prove. If we want to prove that they are not equal, that PQ is not equal to SR, then we want to assume they are equal. Assume PQ equals SR, the opposite of what we want to prove. And the reason for that is just assumption for an indirect proof. Okay? Alright, so if PQ equals SR, what else do we know about PQ and SR? Well, they're bases of the trapezoid. And bases of a trapezoid are parallel, because the trapezoid has one pair of parallel sides, and those are the bases. So PQ is parallel to SR, and that's just from the definition of a trapezoid. A trapezoid is a quadrilateral with one pair of parallel sides, and we call that pair of parallel sides the bases. So PQ and SR are the bases, they have to be parallel. That means that we have a quadrilateral with one pair of congruent and parallel sides. And when we have one pair of sides congruent and parallel, what do we have? We have a parallelogram. That's a theorem. That means PQRS is a parallelogram. But you should be screaming at your screen, because that's impossible. We said PQRSR was a trapezoid. It can't be a parallelogram, because it can't be a parallelogram and a trapezoid at the same time. So if that's the case, we have a contradiction. So we write contradiction with PQRS being a trapezoid. So that means PQ must not be equal to SR. Our assumption must be wrong. And for the reason, I will just put indirect proof. Okay? Your immediate practice problems ask you, if you were trying to write an indirect proof of each if-then statement below, you have two statements, what assumption would you make at the start of the proof? So you're not actually writing a proof. All you're doing is writing down the assumption you would make. Remember, the assumption we make is the opposite of what we want to prove. So in number 1, your statement is, if AB equals 12, then AC equals 8. What you want to assume is the opposite of AC equaling 8. So that's what you're going to write down. What is the assumption? And number 2, if angle C is not equal to angle D, then angle C and angle D are not right angles. So what assumption would you make if you wanted to do this by an indirect proof? What is the opposite of angle C and angle D not being right angles? And write that down. And that is the end of section 6.3.